In this video, my topic shifts to active components from passive components. For active components, transistor is necessary. For different choice of DC bias, which can decide the added power efficiency of the transistor, which is a key parameter we really care about in our design. So in today's video, I will show you the first step to design a active components, which is the DC IV curve sweeping, which can help us find the proper bias point. So here is the schematic. Since we need to simulate two variables, one is the inner variable, it is VCE, and the outer variable, which is IB. Since we want to get these figures, so the inner variable is, you can imagine how we plot these figures. We first set the VCE as the variable and IC is the output. So we first draw this line and then we change the IB. We have the second line and then change IB. We got the third line. So in this case, it is the inner variable is VCE, which is the voltage between the collector and the emitter. So I set this DC voltage to have a DC bias for the collector. And we also need to change the IB, which is the current for the base. So I use this current source. And we want to set them to be variables. So first I use the DC simulator and set the variable, sweeping variable as VCE. And the next is the outer variables. Since we need to simulate two variables, we need to use this parameter sweep kit. So I put it here. The simulation instant name should be the inner variable, which is this one. And the parameter is IB, I set it here. And the start current and the stop current and the step is based on what kind of design you are doing. After we get these settings, we can run the simulation and we will get this plot. But I think you've already noticed it is a little bit different from what we expected. The variable is VCE and the output is LC, but these curves looks a little bit different. It should be in this way, not looks like a flat line. Why it happens? It is because here what we used is a ISP. ISP means a small signal model. For the small signal model, it cannot simulate the DC bias. So we need to use a large signal model to simulate DC bias. It should be this model. They are same thing, but just for large signal, you can see it is a little bit different, but they are same transistors. If we click simulation, and we will have an error. It said Q1 is an instant of an undefined model. Why it happens? That's because this transistor model I used from a library I imported by myself. So we need to include this library into our design here. So the correct thing we should do is add this kit. It's called, this is the transistor company, and we need to include this thing into our RF design. So add this thing, and then we run the simulation. We will get what we expected. Here is the plot as we expected. You can see here, this is inner variables, VCE, and this is output. And the outer variable is IB. It is what we expected. Okay, here is the first step when we want to simulate any active components, which is get the DC IV curve. Based on this plot, we can find the proper DC bias, such as if we want to design a Class A amplifier, we should find a bias point as the middle. It should be around here. And once we decide the DC bias, we also know what's the optimized load for this amplifier. We will talk this later, or maybe in other videos. Okay, thanks for your watching. Good luck with your design.